Okay, so I'll take a minute, and then I'll call on the person who looks the most scared.
I'll go ahead and volunteer.
Okay, Hannah, we'll let you go first.
So, what's the question?
We'll let you go first. You don't have to do, you even have to do all of it. So, just get started. Let's do all of them. So you can have any.
Reflex ratio.
You can pick any of those. You pick the easy ones, the hard ones, whatever. So
XD.
now you start listing these out. Well, this is not, we're not doing the distillation, right? We got 2 plus 2 and plus 5. So, what do you want to specify? What do you specify?
Feed composition.
Okay, feed composition would be C minus 1. Flow rate would be C. Anything else about the feed? Yeah, that's all it says, isn't it? C minus 1 compositions.
Which problem are we doing?
Flow rate. What would you assume about the feed if they don't tell you? As far as other conditions, what's missing? So what would you assume if you're not given anything? That the equilibrium diagram is at constant temperature and pressure, right? So I have nothing, really no choice but to assume that the feed is at the same temperature and pressure as my diagram, right? All right. Allie, what about the solvent? What do we know about the solvent? We give them the composition of the solvent. Okay, that's C minus 1 composition. Are we given the flow rate? Are we given a temperature and pressure? No, but we're going to assume it's the same as the diagram. So notice these both add up to C plus 2. Okay. How do we get this 2 in? Stephen, where do we get 2 in?
Pressure and temperature of each stage.
It could also be temperature and what, I'm sorry, it also could be the what and the Q. It could be Q and P. So it could assume as a bag. Either one is accept the specification and ask them, you can ask them what
Yeah, English term phrase. My replacing keys came from that.
So there's 2 in those because they're in state. All right, we need one more. Do we have one more?
The location of the feed.
Yeah, optimum feed plate, yes.
Graphical composition, no more than 8% acetone. How many compositions? Is it saying 8% acetone, 2% water, and whatever percent? No, one number in it. That's the way it has to be. It has to be that way because I've only got one to go. I've only got one left. So I can only specify one additional piece of information. Could I specify the number of stages? Yes. Specify the number of stages instead of specifying the record. So what am I calculating? In this case, I'm calculating the number of stages. Okay. All right, and we'll talk. So simulation problems are more complicated, just like they are from the K field. just like in the McCabe-Thiele, the easiest thing to do is calculate the number of stages given, specifying XD and XB. Okay. Okay. So now here we, remember we got a simple thing. We got a series of stacked stages, so it's not as complicated. Really? Right? It is 5.4. Oh, okay. It's the same answer. I just wanted to say something. Okay, so anyway, so that checks out. Okay? All right, so now I've given y'all a picture. So yes, this is a straight edge. This is a straight edge topic too. So y'all have this diagram. So we've done MD. Let's draw us a picture of the column. Never hurts. Always a good idea to draw a picture. So E10 plus 1. 85.5 S, 1.00 S. So the S equals N plus 1, you can use either terminology there. There's one raffinate leaving. XA and RN is 0.08. Okay, the temperature is 25 degrees C, and the pressure is 1 atmosphere. This is my best guess. Now, let me just the data given, it doesn't mention the condition, so I'm assuming it because I don't know what else to do because I don't have the information. So I'm confident it's close to it. All right, so we have an E1 here, and we have an R0 here, which we also just call F. I usually just call these F and S, but sometimes calling them R0 and N plus 1 is helpful in stepping things off. We have 250 coming in there. You notice that our solvent is going down and our feed's going up. What is our solvent? What is our solvent? All right, so what's going on here? Why do I got these look like they're going backwards? The density of the trichloro, whatever's got a high density. Chlorinated compounds have densities greater than 1. So in this case, notice the solvent is going. So it's denser than water, right? Or solvent is, which is unusual. So that is unusual, but it does happen. So if you've got chlorinated materials, you have to write that. Okay, so let's do an overall balance. Okay, so this picture here of our stages, we derived it through 3 stages, the octane line, but looking at this one is, I think is good. So that's what our process looks like basically. So we do an overall balance. F plus S equals M equals E1 plus Rn. Right? We don't know how many stages there are. We know F. We know S. We do an acetone balance. That's our solute. Okay, so again, we're extracting, the idea is to extract the acetone out, and then to basically use our solvent, chlorinated solvent to extract the acetone. All right, so we have 38% acetone in my feed. We don't have any in the solvent. But you notice if we did have some in the solvent, that's not a problem. And when you recycle your solvent, you distill and recycle, this number may not be 0. But you can easily plot it, so it doesn't present any difficulties. Notice that we're getting a mixing point. Just like we did for single stage. All right, so let's plot that mixing point. So we're extracting the acetone out of water. All right, so let's plot F. 38% acetone and 62% water. You notice on the right triangle diagram, we don't have the water explicitly plotted, do we? Okay, so it's 38% acetone. And where do we put the point? We know it's 38% acetone, so we know it's where? Very good. Mark pointed out that it'll be right there because there's no solvent in it. Okay? So that's our feed. Okay, and our solvent is 100% trichloro, whatever. That's right there. All right, so F plus S equals M, right? So let's go on and plot, draw the FS line. Say what? What's your question, Todd? Now notice that there was a little bit of acetone in the solvent. That's no big deal. We just plot it right here, right? Where do we plot it? Right here? No, we don't. Where do we plot it? We plot it right there. This line here, this is the y equals x line. All right, so basically that's the edge of your diagram there. Okay, in other words, so 70 plus, 80 plus 20 is 1, so I mean, that's the other edge. That represents no water. That x equals y line represents no water. All right, so what else can we do here? Okay, so let's look at it.
All right.
0.283. So there's 0.3 and there's 0.28. We'll go a little bit up. The 0.29 will be halfway, so let's make sure about this. Notice I could do a better job with 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So 2, 4, 6, 8. I guess right about there would be nice. I'm going to put it there right on the tile line. Yes, that's legal to do that. That's called eyeball estimating, right? But I mean, that's basically where it is. Okay.
That's wrong.
Oh, nice. Yeah. That's really eyeball estimating.
Yeah, okay, wait.
Let's try it 283.
So basically just a tiny bit above 0.28. Okay, so basically, it's right in the middle of everything.